Hello, and welcome to this session by the Posh Wolf, a PowerShell session for the PowerShell Summit 2021, specifically a video on demand. So if you're watching this during the summit, great. If not, great. If you're watching it, great. I'm the Posh Wolf. The link that you see here on this screen is where you can find this session. And specifically, we'll be looking at regular expressions using a couple of different demos. So first off, I am the Posh Wolf. If you meet me on the street, I go by Anthony instead of the Posh Wolf, oddly enough. And here are some fun facts about myself. I am from Eugene, Oregon. I like to do some very Eugene-y things. All my descendants are female, been in IT for a long time. I blog, I tweet, I do a course or two on Pluralsight. I contribute to tech snips, I consult, and I also am employed full-time. And you notice my head's also in the way, so if I move it to the side, there you go. For these slides, I'm putting my head on the left-hand side instead of the right-hand side because I got this nice wolf over in the corner. So next, the things that I kind of expect somebody to need to know before starting. Things like a desire to learn regular expressions more. And I say this because I like to learn by seeing how things are done. So I assume that a lot of people like that as well. And if not, everyone learns differently, so. Basic understanding of regular expressions, so you understand what regular expressions are, how to basically use them. We'll have a refresher, don't worry. Specifically things like character classes, anchors and escapes, and the quantifiers, so you can see them here on this slide. A good way to catch up is, first off, there's a past summit talk by Mark Manassi. I sat in it, I enjoyed it. I highly recommend it if he gets into how the engine works. So how it starts a specific character, moves forward to match, etc., etc. And I also linked the Microsoft docs about regular expressions in PowerShell. I refer to this one a lot while doing this because it's always good to see how it's really supposed to be done compared to how you actually do it. Also, I saw that there was a regular expression talk by Thomas Rayner for the PowerShell Summit. I recommend checking that out. I haven't seen it yet, obviously, because I'm recording this before the summit. But I've sat in these other talks. They're always good. And finally, you should understand PowerShell. It is the PowerShell Summit. So what we will cover. So first off, if you are not super familiar with regular expressions, I will be explaining as I go. So don't worry. Sit back, relax. You can't ask questions. I was going to say ask questions. This is recording. Sorry. Haven't gotten used to that yet. Secondly, we will be talking a lot about groupings. So I like to use regular expressions for more than just validating data. I also like to parse data using regular expressions. And we'll get into that types of grouping. So quickly, what we will be covering, we'll have a quick 5 minutes. It'll be a long 5 minute Regex in PowerShell refresher. We'll cover some demos, specifically talking about the Active Directory distinguished name, the log file example, finding and replacing a VS Code, as well as Regex versus the alternatives. We'll get into speed and efficiency when it comes to using regular expressions versus some alternatives. And finally, the last thing we'll cover, that my head is in the way for, is what not to regex. So believe it or not, there are things that you should not regex. And I've learned this the hard way, so I can have some good experience to talk about. And then lastly, the demo environment that I have, I'm running Windows 10. I am using the latest version of VS Code, and in doing this all in PowerShell 7.1.3. So let's get into it. So before we get into the demos, I want to run through all the different ways you can use regular expressions in PowerShell, just to kind of get you up to speed and potentially have you learn something. So first off, we can use the match operator, and this is typically used to like validate something. So for instance, we have an email address, my email address specifically, and this pattern that we have here. So this is not one that I wrote myself. This is one I found from this link here. We can assign it to a string, and then we can see if that email matches that pattern. To do that, we can just use the email address match pattern. See? And if it does, we have an email address. If it doesn't, you don't. And you can see here that this one is actually an email address, in case you weren't sure. Another way to use regular expressions is with the dash replace operator. So for instance, we have a phone number here. We can use a regular expression to first match the string and then replace it with the different groups in this case. So the $1, 2, and 3, those are all groups in regular expressions. And those are what's inside of the parentheses. Each of those is considered to be a group. And we can make that a little more advanced if we wanted. Use /d for the digits, and then the 3 quantifier. Same thing. This would just match more variances of the phone number. Keep in mind that this is for a US phone number, so we have area code, local code, and then number. So I can't speak to parsing phone numbers for anywhere else in the world. In case this wasn't familiar to you. And we also have select string. So for instance, I've got a sample log here, and I'm going to be doing a select string looking specifically for any errors. So if I run this line, you can see down below that we have 2 errors back in 97, 99. Well, that log file goes back quite a ways. But since we're using regular expressions, I got to escape those square brackets. It's just an example of pulling stuff out of logs, for example. We'll get into a more detailed example in a little bit. And we also have the switch dash regex, and this is one that I don't use very often, so I actually had to look up how to use it. So for instance, if you have a string that has multiple potential values in it that you want to match, like this string here, so I have an email address and a phone number, the switch statement will run each of the potential matches, run the resulting code if it matches. So for instance, I'm only doing this string once, and you notice down below it's outputting that there is an email and there is a phone number. So it's not like a normal switch statement where it only runs it on the first match. So it's just something to keep in mind, can come in handy. And the last place that I want to just briefly touch on for regular expressions is using the validate pattern. So for instance, if you had a function where you want to accept an email address, you can use a regular expression to validate that email address. So the same one we had before, that's exactly what this one is. Go ahead and add this to my session. And we can try to get email address on blah, blah. That is one of the things I don't like about regular expressions and validate pattern is that we get this blah. Like, what does that mean? I don't know. So hopefully the parameter is named in a way that you would expect it to be named, so like email address. And hopefully you also have a help message. I don't have that here. But if I do pass an email address, you can see that it does actually run the function. So this is a short, or I guess long, 5 minutes overview. Let's jump right into the next segment. All right, so before we jump into a distinguished name, I just wanted to point out that my producer stopped by and suggested I get a haircut. So I typically listen to what my producer has to say, so I cut my hair. So I'm still the Posh Wolf, don't worry. So let's run through using regular expressions to parse user distinguished name in Active Directory. So here, this example distinguished name that I have is just a made up one. Don't actually have a directory set up with this. But it's Posh Wolf in Oregon, users in the poshwolf.com. And in case you're wondering, poshwolf.com is my blog. You can check it out if you like. But one of the things when you're parsing data from some kind of structure that is that has rules around it, you can look at the definitions of said thing. So for instance, I've got a link here for the distinguished names, Microsoft Docs about distinguished names. You can look at that if you like. I kind of looked at it to make sure that my regular expression was up to par. It was not. It is now, and we'll talk about that. So to parse this data with a regular expression, we know the string will always start with cn equals. So a user's name is always, a common name, so cn equals. So we can anchor at the beginning with the caret character, and that's caret, not the edible carrot, and then cn equals, and that's going to be the start of our regular expression. And then for the common name, we can, in reading through the definition of what can be used in a common name, we can use anything but a backslash or a comma. And obviously there's some more restrictions. It just would make the regular expression really complicated. And for all intents and purposes here, I'm assuming that whatever distinguished name that I'm parsing is a valid one, and I'm just getting the data out of it. But you can have a comma that is preceded by a backslash. So a backslash followed by any single character, which is what the period represents. So we can do one or the other. So we'll combine them inside of parentheses with the pipe character. So you can see that here on line 18. And since the common name is going to be one or more characters, we have the plus sign there to be one or more characters. And so we combine that with the start of our regular expression. And we can highlight this and run this match. And you can see here that that matches, which is good. Not that I was worried about it. But whenever you use the match operator, you always get the matches automatic variable. That's what we have here at the end of the line. And we can see here that we have the full string that it matches. So that's the group 0 and then F. So in this case, the group that we have, so everything inside of parentheses is considered a group. And in this case, the parentheses here represents one character and then the plus sign. And so that means that the last character that that group matched on was the F. And it's not really useful, and that's where we can use non-capturing groups and named groups. So I'm making that group non-capturing by the question mark colon, and then creating a named group that captures the entire common name. So you can see that notation here, the question mark, and then the inside of angle brackets, the CN. And from here on out, I'm just going to have matches on the same line, so I only have to run one line just for convenience. And so now you can see that it both matches and we have a CN. And so we can access that CN by doing a $matches.cn. So you see how this can be really useful for parsing data out of there. All right, now that we have the CN part, we can go ahead and move on to the path. And so I'm going to assign this CN section, call it the user regex. Assign it the user regex variable. And so we know that the user is inside of either a container or an OU. So we can do OU pipe container inside of parentheses. And the name of that container or OU is roughly the same requirements. And for our intents and purposes here, we're going to assume it's the same requirements. And we're also going to make that a non-capturing group. And then the user could be in multiple OUser containers. So you'd notice that we have, so up above here on line 38, we're using the plus sign for the name of the OU or container. And that's for one or more. And here we're using an asterisk for 0 or more. So the user could be in the root of the domain. So we have to account for that. So that's what we're using the asterisks for. And so now if we try to match this, it does match, which is good, and we get these funny groupings here that we don't really want. So what we'll do is we'll add, first of all, make all the groups that we don't care about non-capturing. So you can see the addition of a couple of question mark colons there inside of the parentheses. But we're also capturing the path that the user is located in, and so you can see that name group here that includes all the way up to the asterisk. And with those groups, you can see that that path now has OU equals organ, OU equals users. And ultimately, we'll also have it include the domain portion, the DC equals, and etc. Speaking of the domain portion, let's run through this. So we'll add the path regex to the path regex variable. And with the domain, this is going to be pretty simple. We know it starts with DC, so we have DC equals. And for the name of the domain, this is where we can take a look at lookarounds and regular expressions. So the domain name has a pretty strict character set, uppercase, lowercase, numbers, and the hyphen, but it can't start or end with a hyphen. So here on line 60, we have a negative look ahead saying that the first character cannot be a hyphen. So that's what's inside of those parentheses. So a look ahead in regular expressions is where the cursor doesn't actually move when it's checking. And that's really important because you can match something or say that a string starts or doesn't end with without actually capturing that if you want it. So in this case, we do want to capture it, so that's where you still have the character set. So in between the look aheads, we have the character set, so the uppercase, lowercase, numbers, hyphen, and that's one or more, so that's where the plus sign. And then at the end of it, we have a negative look behind, so that's where the angle bracket exclamation point comes in, and then we're saying it's not a hyphen. So lookarounds are really confusing. I understand that. And I'm only able to explain them here because I looked them up to be sure right before this. So for the domain, we now have DC equals and then the name of the domain. And we also might be in a subdomain. So maybe we have, a sub.domain.com, right? So we want to account for that potential. And so specifically, we're accounting for that by using a plus sign. So we're saying one or more domains because we know we have to be at least one, could be multiple. And then we also have the TLD at the end of it, and the length of the TLD is an acceptable TLD is between 2 and 6. So that's where at the end of it here you can see I have the 2 to 6 instead of the plus sign for the TLD. And I'm also assuming that cannot start or end with a hyphen. Though thinking about it now, I don't think you can have a TLD with a hyphen. Interesting. Probably should have looked that up. But remember, we are assuming that the distinguished name that we were getting is already valid. So we're not doing a lot of validation. We're parsing it for data. And so here on line 72, we can now match with all of the regular expressions. And you can see we have the different DC equals. We don't care about those groups. So if you look, let me scroll over a little bit. This line's getting kind of long. You can see now I'm making those groups non-capturing with a question mark colon. Now if we run this section, you can see that we now have our path, our CN, and the domain. The only issue is that the path doesn't include the domain, and that's because I have them split with the variables. So if we look at the final product, you can see that, wow, this is a lot of regular expression. I'm not a fan of huge regex, but if you break them down and run through them, then it makes this process a little easier. And so now you can see that the path now includes the actual entire path that the user is in. And we can see the CN and the domain as well. So that's how you can parse an Active Directory distinguished name using PowerShell and regular expressions. So let's jump into the next section. All right, so one of the difficulties with using regular expressions to parse log files is that they're all different. And the ones that are the same already have parsers, so you don't have to worry about that. But in this case, I've got a log file. Let me just show you what it looks like. That'll probably be the easiest way to start. So this log is produced by an application that syncs data from ADP to Active Directory. So on this first line, you have the source. So this is the ADP ID, first name, last name, email address, and then the destination, if it matched. And then all these lines below are different properties that are different in ADP than they are in Active Directory, and the application will update them. So in this case, you can see the work email is being changed, though in my sanitized log, they're actually the same. Same with the username. But the department, for instance, is blank, and it will then be updated to Department of Regexing. So this is a project where I actually did to be able to parse this log in a way that I could send this over to HR, and they can say, well, yep, this is right, that's right. Oh, this isn't matched to the right person, that sort of thing. So let's run through this example. So first off, I have it listed here already. Open the log file. So we have this. We have three distinct things that we have to be able to parse: the source, the destination, and then the different properties. Also, let's start with the source. So here we are. We're going to assign it to the source variable. So we can start here by anchoring to the beginning of the line with the caret, source, colon, and then we know we have the two curly braces. And then inside of the curly braces, and I'm going to be really a little bit cheeky here. So the ADP ID I know is going to be alphanumeric. So that's why I have the /w, which is word characters, alphanumeric, and I think it's like underscore as well, maybe a couple other things. And then the first name, last name, I took a character set that matches all the uses that we have. So upper, lower, numbers, dashes, underscores, and then even the single quote in case of the people that have some fancy last names or first names potentially. Then we have a comma, and then we have, and I did something really easy here for the email, I'm saying anything that's not a space. So remember, inside of square brackets, if you start it with the caret, then it's saying anything that's not whatever's in that character class. And you could use an email address regular expression here, but I know that email address is already valid, so I don't have to get super fancy on that. And if we do this, we can see that it does match. So now we just need to get the ID, the name, and the email address. And so you can see here on line 40 that I can grab those really easily by throwing those different character classes into in parentheses with a named group. And pretty simple. We got email, name, ID now. Great. So then let's look at the destination. This one's going to be really similar. So again, we can anchor to the beginning of the line with dest. And we can be really simple again. So for the email address, anything that's not a comma. So a comma is not a valid character for an email address. So we're doing one or more of those. And then for the first name, last name, we could use the character classes and then include parentheses, but we could keep this really simple and just say anything that's not a closing curly brace. Hopefully we don't have anyone with a name that has a closing curly brace. And if we run this match, you can see that, yep, it matches, and then we'll add the groups to it. So we'll capture that email address, we'll capture the name, and there we go. Now we have the email address and the name. In this case, the name is a little more complicated. We got first name, last name, space, and then inside of parentheses. We could parse that out, but I made the design decision to actually use the name, the first name, last name that came out of the source, because we're assuming that ADP is our source of truth. And so now for the properties. So we have two cases we have to match for. In this case, we have prop one, what I'm calling prop one, where the value is null in Active Directory, but it will be updated. So you can see old equals, and it's just double quotes. There's nothing in between them. And then new equals, and there's a value in there. And then we also have to count for here on line 62, where there is a value in old, and there will be a value in new. So what we're going to do here is we're going to anchor to the start of the line, and I'm going to say anything that is not a space or a space character. So slash lowercase s is a space character, so space, tab, that sort of thing. Slash uppercase s is anything that's not one of those. So I know that none of the properties will have a space in the name. And then a plus is one or more. So it's going to be, it's going to have an entire property name. And then we know it's always going to say is different, old equals, and then new equals. But here on line 65, I'm specifically calling out, I have a star in the first property value section. So inside of curly braces, I'm saying anything that's not a double quote star. So 0 or more. And then for the new, I'm saying anything that's not a double quote plus. So 1 or more. I know the new always has to have value. So I can say 1 or more for the new. I can say 0 or more for the old. So now we can try this regular expression with the first property. It works. And the second property, and it works. Hopefully you weren't on the edge of your seat there, because I knew that was going to work. So then we'll add in named groups, so we can get the name of the property, we can get the value for old, and the value for new. So here you can see on the string that doesn't have an old value, we get everything but the old value, because there's nothing there. And on the string that does have the old value, we have that old value. And on both of them, of course, we do have the prop name. And then the difficulty becomes, how do you parse the whole log? I don't want to get too far in the weeds here because this is beyond regular expressions, but we're going to grab the log, we're going to grab everything that's in there. I'm going to store all these regular expressions in these regular expression values. And then what we're going to do is we're going to iterate through the log. And you notice here on line 89, any line that's not like dash dash dash, because the separator in the log is a dash dash dash, and we can see that here. So between each entry is dash dash, lots of dashes. So anything that is not like dash dash dash, we're going to try to match it to the property regular expression, to the source regular expression, and then to the destination regular expression. And then whichever one matches, it's going to assign it to a hash table and store it. So if we run this, and like I said, we're talking regular expressions, so I don't want to get into, what I'm doing with the rest of the code here. But now if we look at one of these items in here, so I'm creating a hash table that is, the keys are the ADP ID, and the value is the value of that object. And we convert it to JSON. Because this object has nested properties, it's just a little easier to view in JSON. So there you can see that I have all the for the division, the old, the new, the department, old, new, all this good stuff. And then ultimately what I ended up doing is converting this to a spreadsheet with old column, new column for each property, and then our HR department was able to provide me some good feedback. So that is one example of how you can use regular expressions in a log file. Obviously, log files are, everyone does their own thing. But hopefully that can help you with any future attempts that you have. So let's get on to the next section. All right, so let's look at using regular expressions to find and match stuff in VS Code. Specifically, we're going to look at some PowerShell examples. I'm going to be looking at a module I wrote, and specifically this one talks to an API, and the module was designed so it could talk to multiple endpoints, so multiple organizations. So I designed the module to store the config in this JSON file so it can import it and work with it. So I designed the config so that here on line 3, we have an org setup. So this org is called example, and it has a location, access token, and then it stores the refresh token as well as the token expiration date. And those tokens are for use with an OAuth API. And I designed it so that we could have multiple orgs that it could talk to, and by setting the value here on line 10, you could switch between orgs. But when I wrote this, the config was all done in such a way that I could use it for other API modules as well. So let's just take a quick look. So for instance, you see here the function name get zcrm config. If I ever wanted to use this for a different API module, I'd have to rename all the variable names. As well as you notice here, I'm also referencing the org specifically. So maybe I wanted to write a module to talk to servers or endpoints or something different. Each one had a different config. Well, I'd have to do a lot of find and replacing in here. And let's run through a couple of examples of how we could do that in VS Code and regular expressions. So in VS Code, if you want to search in a particular folder, you can simply right click on the folder and click on the find in folder option. And here's where you can put in what you want to search for. So in this case, I have a regular expression I've prepared. But you notice that it doesn't find anything, and that's because we don't have regular expression search turned on. So I'm going to tell us to use regular expressions. So specifically, I'm looking for anything that is org or orgs. So that question mark following the S just means that it's one or none of the previous character. And I also have it grouped, and I'm doing that because if we want to replace it, say for instance we want to replace it with server, and we want to replace org with server and orgs with servers. So what we can do is, since we group the S, we can refer to that group with the $1. And the nice thing about PowerShell is you're used to variables using the $sign to precede it. So it's the same thing in regular expressions. So down here, let's expand this out just a little bit. You can see, for instance, that orgs now is servers and org will be server. Great. And I'm going to go to new replace all. And it's of course going to warn me, and that's fine. I've already checked all of those 30. So the other thing we can do is replacing the noun prefix. So this one is -zcrm. And let's say I want to make it -demo, right? And that was pretty straightforward. It's not actually a regular expression. It just was one of the steps that I took for this. And the last one, this is the fun one. This is where we can look at another negative look behind. So what if we need to change all instances of $config, but when the config is declared, it's actually declared as a script variable, so a script scope variable. So what this means is we need to match on $config or $script::config. So got a regular expression here. So here I'm looking for config, and then script : is in parentheses, so it's a group, right? And the question mark follows that, saying that either that there is one or none of the preceding group. So script could be there or could not. And I have this look behind as well. So I want to just show you something with PowerShell, and this is because PowerShell uses $signs and regular expressions uses $signs as well. I mentioned it's really convenient, but it can also be a little difficult. So if, for instance, we want to say the string starts with $sign, In regular expressions, the $sign is an anchor, so we have to escape it. But now if we want to replace it with a $sign, and since script is in a group, I want to reference that group. I can reference that group with $1, and then we can say config. And so if you look down below, you can see that it's replacing $config with config, and script config, script config with script config. And if we want to put an additional $sign, we can escape it with /1, but then that screws up our other grouping as well. And so that's where we had the look behind, saying the first character should be a $sign. And since it's a look behind, that $sign is not included in the match. And so we can still replace everything without having to also replace the $sign. And then down below, you can see that now script config is script config. And if we do a find and replace, you can see the two examples on my screen. You can see the two examples on my screen didn't actually change because what I wanted to do was replace it with something different. And so now we'll actually replace it with something different. And you can see now that you have, so you can see now that we have script module config and module config. Perfect. So that's just a couple of examples how you can use regular expressions in PowerShell scripts. So in that specific example, instead of doing a find and replace, you should really look at doing a plaster template, which is what I'm working on because they do template files, which is pretty cool. But yeah, let's jump into the next segment. So one of the things with regular expressions is once you learn it, you tend to want to use it for everything. And I know this because that's what I did. And I just want to walk through a couple of examples of comparing regular expressions to some potential alternatives. So doing like splits and substrings, string stuff. So let's run through an example with that distinguished name and the log file. So I have that distinguished name here, and I have the regular expression here. And what I want to do is I want to run this 10,000 times. See how long it takes. I wonder if this is going to be very long. So we run it, you can see that it takes 106 milliseconds. Not bad. And another way, and I've been doing this a couple of ways. Another way we could split up that distinguished name is by splitting it here on line 16 and then grabbing the rest of it through joins. Actually through joins or specifically indexing into it. And so if we run this, you can see that we get the same values, just to show you. But the problem is this process is very slow. And so you can say it took 1.5 seconds, a little more than that even. So about 15 times as long, which is not good. But another way we can do this, and this gets really difficult to read, more difficult to read in regular expressions. I don't know. They're both can be pretty difficult to read. But if we look here, I'm doing substrings. So I'm finding the index of different characters and doing substrings to get what's in between them. So if we look at this, we can see that we still get the path to C in the domain. Cool. But if we run this 10,000 times, oh, it's half the, that's a lot faster. That's probably the fastest I've seen it do that actually. Let's do that again. There we go, 55 milliseconds. And up here, we're still looking at, 87 is a little better. Let's add a 0 here. I'm actually curious to see if we make this. So I'm curious to see if we make it do this more times, if it's what the difference is. So we got 700 milliseconds for the regular expression. And for these substrings, we got 600. So, well, a little less than 600. So it's actually, in this case, it's faster to use substrings. But is it more readable? Let's look at a more complex example. So this log file. So I'm gonna add the strings and those regular expressions into my console here, and we're gonna do 100,000 times. We're just gonna do it a lot, because that way we can get a better gauge of how much faster it is. And so we have our regular expressions. We're matching each the source once, the destination once, and the property once. Now obviously when I was writing the script, the property matched multiple times, but just going to do this one each. And so if we run this using regular expressions, it takes about 1400 milliseconds to match each of those strings once 100,000 times. And this is where the substrings can get a little ugly. So for the source, you can see I'm looking at where the commas are and doing my substrings based off of that. So there's the source. And for the destination, the destination is a little easier. I'm just getting what's in between the curly brace and the comma. And that's how I'm doing that. And see, name, email, pretty straightforward. But for the properties, this is where it gets a little more complicated. We have I'm getting the indexes of all the quotes and then getting substrings between them. And remember, this is regular expression, so I'm not going to go into detail here. But if we run this 100,000 times, it takes 1900 milliseconds, so 2 seconds, so about a third longer. So instead of 1400, it's taking almost 2 seconds. And just for kicks and giggles, let's run them both again just to make sure we're giving them a fair chance here. So there, we got almost right on 2 seconds. And yeah, actually both coming back about the same amount of time. So in this case, regular expressions are a little faster, but you always have to ask yourself what's going to be easier to read, what's going to be easier to maintain. And in really complicated scenarios, regular expressions might be faster, but they're not always easier to read. But is something like this easier to read? It's gonna be a decision that you'll have to make. It's not always clear. Like the performance issue is a clear one, which is why I can show this to you. So anyway, let's jump into the last segment, my favorite segment. So when you learn regular expressions, and I'm speaking from experience here, obviously everyone's different, but when you learn regular expressions, you tend to want to just match everything. And I can tell you right now from experience that you shouldn't. And we'll get into the real reason why you shouldn't at the end of this, but let's look at a couple examples here. So HTML, this is my favorite one because I've parsed HTML with Regex before. It was a lot of work, it wasn't pretty, and it worked for specific instances. But the reason why you shouldn't is because there are parsers for HTML. People have spent hours and probably days, weeks, months, years building out these parsers. And if you do parse HTML with regular expressions, you're evil. And if you want to know more about that, there's a really good Stack Overflow post about how parsing HTML with regular expressions makes you evil. And I suggest reading this if you have a chance. It's in the code here. It's in the repository. That's how you can find it. But here's an example, and I didn't actually write regular expressions to parse HTML because you shouldn't. Instead, I want to show you how to parse HTML the right way in PowerShell. So my example, I'm specifically using a module that has the HTML parser in it already, PS parse HTML. So this module is really convenient because it has a parser already loaded into it. And there's quite a few commands in there that have some built-in conversions. So for instance, we have this table. So the beauty of a module like PS parse HTML is it means that we don't have to write a lot of code. Well, you're part of the PowerShell Summit. I'm sure you love writing code. But in this case, we don't have to write the code to convert an HTML table to a PS object. We can simply use the module to do it for us. Great. I've got a lot of use out of this specific function for parsing HTML tables, so out of wikis or tickets or that kind of thing. Another really good one is XML, and believe it or not, there's a parser for XML that you have access to. I've never actually seen anyone try to parse XML with regular expressions. It's just one of the ones that PowerShell has a parser, so don't worry about it. So specifically here we have this XML data. And if we assign it to a variable that is typed as XML, like we have here on line 58, it will automatically parse it for us. .NET will. So we do that, and now we look at XML.note. we can see all that data in there. Great. Another one that I've run into is a URL. So you can write a really cool regular expression to parse a URL. It seems pretty straightforward. You know, you have your query on the right-hand side of the question mark, and then all your parameters joined with the ampersand. But you shouldn't have to worry about this because there is a parser for it. I sound like a broken record, but this is really important to understand. So for instance, here on line 76, I have the URI for doing a search on Bing for PowerShell. What can I say? Microsoft makes PowerShell. They also make Bing, so why not? And with .NET, and even in .NET Core, remember I'm PowerShell 7.1, we can parse that URI with system.uri. And you can see down below, I'll expand this up a little bit. You can see that we have a lot of good information about this. So the path URI, the local path, the query, a lot of good stuff. So don't worry about trying to parse it yourself. You should just use .NET. And then finally, what I really want to make sure you are taking away from this final segment is that you should spend your time writing code that does the things that make you productive. So what that means is that, for instance, I am not paid to write an HTML parser. I don't want to be paid to do that. That sounds like a lot of work and not something I'm really interested in. But you know what? I can be productive by parsing, a documented wiki table from HTML and pulling that data and doing something with it. And I that's a use case that I actually use for being able to parse an HTML table. But I don't have to spend the time to write the parser because at the end of the year, my performance eval, Anthony wrote a really good HTML parser and PowerShell regular expressions. Yeah, that's not going to happen. They don't care about that. So anyway, that wraps up my PowerShell Summit presentation. I really hope you enjoyed it. If you have feedback for me, follow this link you see here on the slide. And you notice I have a SurveyMonkey link you can use to give me feedback. So if you have positive, negative, doesn't matter. I appreciate when people give me feedback either way. And if you do want to find all this code here, it's here. I have it branched out because it's still in the works. But now that I've recorded it, assuming I don't have to re-record this or any of this, I'll go ahead and do a PR into the main branch and get that in there. But anyway, thanks again for watching. I really hope you enjoy the summit. I do every year.